Good morning. Welcome to the first lesson in our probability and statistics unit. If I have you as a student this year, and the year I'm recording this is 2020-2021 school year, then we're going to be doing this unit differently than we've been doing the other units this year. So please stay tuned in class to the announcements for that. What I'm going to do, and I actually had all of these photos uploaded to Dropbox from last year when I did these lessons virtually. What I'm going to do is actually upload into this video a copy of the outline of the notes. The outline is available to you either in class as a hard copy or online where you can access a copy. And so you should be able to follow along with the lesson as I go. And voila, there we have the outline of the notes. And if you have a hard copy, you'll note that this is simply like a screenshot of the hard copy that you have with the group activity taken off the top. So you do want to make sure that you're paying attention in class for what to do with that group activity. In a more normal learning environment, we would actually start the class with that group activity. And then we'd move through the lesson, and then there's an activity at the end. There's actually 3 activities that go that we do in this lesson, and of course, being virtual or it changes what those activities look like. So just make sure you're listening in class. With the probability, there's a decent amount of the probability that is conceptual as opposed to calculating. So there's not a lot of equations you need to solve, lots and lots of word problems. So you are going to be getting copies of the outlines for most of the lessons here. In this first lesson, we start with some vocabulary here. And so the first vocabulary word that we have is sample space. And so when you're reading word problems and stuff, you might hear the vocabulary sample space, or you might be asked to identify the sample space. So obviously you need to know what that means. The sample space in a probability problem is the set of all possible outcomes, and this might not work super well just because of the size of it on the screen that I'm writing on is smaller than a laptop screen by a lot. It's the set of all possible outcomes to an experiment or an activity. So first blank is outcomes, second blank is experiment or activity. Now I want to say something about the word experiment. So when you hear the word experiment, you might be thinking of something really cool looking, like a chemistry lab with bubbling flasks or whatever. But in a probability, an experiment is just simply an event. It's just something that happens, like a trial that you might do. When we're first studying probability, our experiments are really simple, like rolling a die or picking a card out of a deck of cards and so forth, because we want to focus on the concept. We don't want to make the actual experiment really complicated. But as you progress in the study of probability, then things get really, really complicated. And in the sample space and the experiments and the outcomes don't necessarily, they're not always very obvious. So a sample space is a set of all possible outcomes to an experiment. If you did the group activity, okay, and you did the activity with the folding of the card, okay, then your sample space was all of the possible outcomes. Okay, it was all the possible outcomes. So you fold the card and then you try to think through, if I drop this card, what are all the possible ways that this card could fall? And then that becomes your sample space. Now, within a sample space, we are usually interested in a specific outcome. Equally likely outcomes are outcomes that have an equal chance of happening. A little bit of a circular definition there. We're just like clarifying what we mean. A circular definition is when you actually use the terminology to define the vocabulary you're trying to find. So you use the word in it. So equally likely, and then we use equal chance like within the definition. But some examples of equally likely outcomes might be this. I have in the notes, rolling a specific number on a die. Die is the singular for dice. A lot of times we talk about rolling dice, and that's plural. And then if you only have one, it's called a die. So if you have a regular standard 6-sided die, it's got like the numbers 1, 2, 3, 4, 5, and 6, and there's an equal chance of rolling any one of those numbers. So if I roll the die once, I have an equal chance of rolling a 2 as I do a 5, because yeah, there's 1, 2, and 1, 5. Sometimes an outcome is referred to as an event, which again, when you think of an event, you might think of a rock concert or prom or something. And usually in probability, an event is something as just exciting as rolling a die. Now, we're usually interested in a specific outcome when we're talking about an event. So for the last year or so, we've been going through COVID-19. Recently, we've got like a lot of news about vaccines and stuff. And the outcome, when we're talking about vaccines that we're usually interested in is whether or not somebody can get COVID after they have the vaccine. So you have a bunch of people like get a vaccine, okay? And that would be like your sample space. And then we're interested in like of that sample space, people that receive a vaccine, how many of them contract COVID versus how many don't. And so we're interested in like, what's the probability of somebody getting COVID once they've had a vaccine? And of course, like in real life, it gets complicated because we know there's like symptomatic COVID and asymptomatic COVID. There's severe, like the kind that lands you in the hospital, and then there's mild, the kind that doesn't. And so in real life, things get complicated. We don't start off with like these super complicated ideas. We try to keep it simple. So sample space, the set of all possible outcomes to an experiment or an activity. Within the sample space, we're often interested in a specific outcome, equally likely outcomes that have an equal chance. An example of that, you pick like your regular 6-sided standard die and the probability of rolling any one specific number on that. And then sometimes an outcome is referred to as an event. Now, within the probability, there are two kinds of probability that we talk about. One of them is theoretical probability. So we're going to do a definition of that. Theoretical probability is the probability of an event occurring as calculated. So this first blank here is calculated. As calculated by dividing the number of times that outcome can occur. So that outcome can occur, OCCUR, okay, by the total number of possible outcomes. So for this, you would not actually roll the die. You would look at the die. You would note what all of the possible outcomes are, like what's the sample space, and then whatever event it was you're interested in, say rolling a 2, you would look at how many times you could roll a 2 and then put that over the total possible outcomes. Now, the notation, the probability that event A can occur is denoted, let me like use a different color. The word denoted has to do with the way something is written. So we use that when we're talking about like the way we denote a function is f of x. We're talking about the type of notation that we use. So the notation for it in math is going to be a capital P. P stands for probability. And then in parentheses next to it, you will have the capital letter A for event A. So you would read this out loud, the probability of event A. Okay, that's what that notation means there, the probability of event A. Now, a lot of times you'll put something in there, you'll name the event by something that you're interested in, whatever you're interested in. So you'll notice here, if you look down on the notes there, it says, let's go back to the warm-up, which of course, because we're doing class differently right now, maybe we don't have a warm-up, but what is the probability of rolling a 5 if you're talking about a regular standard die? Notice that in notation there, you've got the 5 there. Okay, my iPad just did something really weird. And that would be read as the probability of rolling a 5. Notice that it is not multiplication. Okay, this is not P times A. In fact, when we're talking about probability and statistics, we're not in the field of algebra. anymore. Probability statistics is a different branch of mathematics. So we're not applying our algebra notation to this. We're actually using more our set notation. And we might do a lesson on sets at the end of this unit. I did upload it to the iPad with the notes, but I don't know if we'll do it or not. So let's talk about rolling the probability of rolling a 5. In the example of rolling a die, you could roll a 1, a 2, a 3, a 4, a 5, or a 6. So that is the sample space. So that you might be asked, like, list the sample space. That's what you would be asked to do, like 1, 2, 3, 4, 5, or 6. So now to calculate the theoretical probability, we're going to look at the number of times that particular outcome can occur. So on this, if we're talking about the probability of rolling a 5, there is one way to roll the 5. So the probability would be 1. And then if we go back to the definition, divided by the total number of possibilities. And so if we count, there are 1, 2, 3, 4, 5, 6 different possibilities. And one of those 6 ways is the number of ways that we can roll a 5. So that's how you do your theoretical probability. It does not involve actually rolling a die. It has to do with knowing what's on a die. So the next question down there, which is at the very, very bottom of the screen there, it says, what is the probability of rolling an even number? So you have your die, you're going to roll it once. So you look at your sample space, which is, remember, the total number of ways that outcomes that can happen. And then we want to know the probability of rolling an even. And so the denotation for that might look something like this: probability, and then in the parentheses, the event or experiment or outcome that we're interested in is rolling an even number. So we want to look at the total number of ways that that event can occur. In other words, what are the total number of ways that you can roll an even number? Well, I can roll a 2, I can roll a 4, or I can roll a 6. So there are 3 ways that I can roll an even number divided by the total possible outcomes, or outcomes in the sample space. It's 3 over 6, and most of the time you will want to simplify that fraction as much as possible. Probability can be expressed as a ratio, a decimal, or a percent, and you should be pretty fluent in moving back and forth between them. Which way is better is determined by what you want to do with it. So first and foremost, as a math student, you always want to read the directions and always leave your answer in whichever form the directions ask you to. So if it says leave as a simplified fraction, you leave it as a simplified fraction. If it says leave as a decimal rounded to 2 decimal places, then that's what you do. If it says leave as a percent to the nearest tenth, that's what you do. Outside of being a math student, you would leave your probability in whatever form was the most useful for you. And so 1 out of 2 or 1/2, that's actually pretty useful. But if you had a fraction like 3/46 out of 5/27, that's not as useful of a number. It's just the numbers start to get big and it starts to become more difficult to get a handle on exactly how big it is. So that's when you might convert over to a decimal or to a percent. And it's why a lot of times you see probabilities expressed as a percent, because it's that common denominator of 100 out of 100. Right. The other type of probability is something called experimental probability. And we'll go ahead and define this. This is the probability of an event occurring as calculated from an experiment. Hence the name experimental probability. So while the first, sorry, I wrote right over my writing there. In the blank is the words an experiment. So in theoretical probability, we don't actually do any rolling of the die. We list what we know about a die, and then we calculate the probability based, like, in theory about what we know. In experimental probability, we actually are going to conduct the experiment. So we might actually roll the die and see what happens. What we do is we divide the number of times the event actually occurred by the number of trials that we conducted. So for example, and I might do this in my face-to-face classes. I might not, like this first lesson has a lot of activity stuff going on in it, but here's what we would do in class. I actually have in my classroom these huge dice. I actually have a couple of them. And what we'll often do is roll them around. Now, in a more normal classroom environment, we can like toss them to each other, roll them around on the floor. We don't have to deal with the desk shields and the stuff that we currently have at the time of the recording of this video, which makes it harder. But what we actually do is we roll a physical die. It says in the notes 12 times, but we usually roll it closer to 30 times. And then we actually calculate how many times we roll a 5 out of the number of trials. So what I'm going to do for the purposes of this video is I am going to, here in my apartment where I'm recording this, I'm going to go ahead and roll a die a whole bunch of times, and we're going to collect some data on that. Okay, so you guys missed the thrilling me rolling my die like over and over and over again, just here with my notebook, rolling it. And again, normally we would do this in class, and I think there's another video on the YouTube channel somewhere where I went through and just rolled the die that I recorded last year. I just kind of did like a live video where I did it. But this is what I got. I kept rolling until I got to what I thought would be a nice number for stopping. And so I think I have 50 rolls here. So here are the results. I rolled a 1 7 times, a 2 12 times, a 3 7 times, a 4 4 times, a 5 13 times, and then a 6 I rolled 7 times. So that's like 20, 24, 36 plus 14 is 50. Okay, so this is based not on theory, and it you just have to take my word for it that it's like on a regular die, and then and I just rolled it. So this was based off of what I actually rolled. So looking at what I actually rolled, the probability of rolling a 5, going to the definition of our experimental probability, it's the number of times the event occurred. And so if I'm talking about rolling a 5, that event occurred 13 times out of the total trials conducted, which would be 50 trials. And that's a little bit harder to get like our head around in terms of comparison. So I'll show you the usefulness of the different ways that we write it. Now the probability of rolling an even number, we want to look at how many times I rolled an even number. So even number trials, I rolled 12, 4, and 7. So those are the number of times I rolled an even number, and that is 11 plus 2 is 13, which is 23, and so that would be 23 out of 50. Now let's go back and compare those to the theoretical probability for a moment. Theoretically, now the theoretical probability of rolling the 5 was 1 out of 6. And it's a little bit tricky to compare 1 out of 6 to my experimental. So what we're going to do is actually change those over to decimals. So theoretical probability of rolling a 5 was 1 out of 6. So what I'm going to do is actually convert that over to a decimal. So 1 divided by 6 is equal to 0.16 repeating, or if you wanted to change that to a percent, it would be about 16.7%, because you take that 0.6 repeating and round it up to the 0.7. Experimentally, my probability was 13 out of 50. And so I'm going to go ahead and take my calculator and divide that out, and that ends up being 0.26 or 26%. So to convert from a decimal to a percent, you just move the decimal point 2 places over. That in this case, my experimental was substantially higher than my theoretical, because for whatever reason, I rolled a ton of fives. And if you watched me roll it out, like there were times where I rolled like 3 fives in a row. Not likely that it'll happen, but it's certainly possible that it would happen. The probability of rolling an even one we calculated was 1/2 or 0.5 or 50%. Okay. And then my experimental was 23 out of 50. And 25 out of 50 would be the 1/2. So it's going to be close in this case. And this is 0.46 or 46%. And some of that is because I obviously rolled a disproportionate number of fives. And so it kind of jacked up the odd numbers. And also, for whatever reason, I did not roll many fours at all. And that happens when we do this activity in class too. I've had trials that I've done with classes where we haven't rolled a 3 at all. And the kids start to wonder if the die is a real die because we'll roll it like 30 times and we'll never get a 3. So experimental can be a little bit unpredictable. Something I want you to take away from this is, one, you don't always know enough information to be able to do theoretical. So if you're actually like a scientist and you're investigating something for the first time, you actually don't know enough information to find theoretical probability. So going back to vaccines, when we say what's the probability of getting COVID if you've been vaccinated, we don't actually know that. That's what we're trying to find out. And so the only way to be able to come up with that is to do experimental. The other thing is that your experimental probabilities will become closer to your theoretical the more trials you can conduct. So sometimes you'll hear, I think it was the AstraZeneca vaccine, that they didn't apply for approval in the United States. It's been at this point been being used in other countries in the world, but not here. And one of the issues with it is that certain populations, there weren't enough people in the phase 3 trials. And so to get better results, you always want more. So if I kept rolling the die, if I kept going for like another 50 trials, what would happen eventually is I would get some more 4s and I would go kind of a stretch of time without getting a 5. And these numbers here would start to close in on the theoretical. So that's something important to remember. Now, there is an activity that we will do in class that has to do with rolling 2 dice and the sum of the dice on there. And so that's what we'll follow up this lesson in class.